talking about nomenclature now, which simply means naming to chemists. We're going to start with the simplest example. We're talking about ionic compounds now. And if there is no transition metal in the ionic compound and no polyatomic ion, they're quite simple to name, okay? You always name the cation first, and the cation has the same name as the element itself, okay? And then all you do when you go to name the anion, it has a name that sounds pretty much like the element it's made from, except you have to make sure to use a suffix of IDE. So let's look at an example. KCl would be named, K is the metal, remember the metal always goes first, and it has the same name as the element itself, potassium. Chlorine is the anion, so you have to remember in the anion to use the suffix IDE. So instead of chlorine, we say chloride. Same thing, calcium oxide. First you check and you say, okay, calcium is not a transition metal, and I don't have a polyatomic ion in here, so I'm going to name the metal like the element itself, calcium. And I know this is oxygen, but I'm going to change it to oxide because of the rule about the suffix. Not too hard. All right, now let's talk about if we have a transition metal, because that's quite a bit trickier. All right, so because transition metals can have different charges, you need to be able to tell the reader which charge the particular compound has in it. So in addition to naming the cation, like remember we said calcium or potassium, in addition to the name of the cation, you also need to put the charge of the transition metal in the name itself. We do that by using a Roman numeral to show the charge, and we put the Roman numeral in parentheses. So iron, which is a transition metal, as I said before, can have a charge of +2 or +3. If the compound you were talking about was made from iron with a +2 charge, you would start out by naming the compound iron, then you would put parentheses and Roman numeral 2 to stand for the charge. All right, so let's actually do a name. If you see a formula, again, the first thing you should always ask yourself is the metal a transition metal? Is it in the middle of the periodic table? Chromium is, so you're like, uh-oh, now I have to find the charge on this chromium before I name it. How do I do that? The first thing to remember is that the overall charge of any compound, ionic or otherwise, has to equal 0, the overall charge. So whatever the anion total charge is, that must be the same as the cation. And so that's how you figure out the charge on the metal, cation, is you always know what the charge on the anion is, so you kind of back into it. So let's look. A bromine has a charge of what when it becomes an anion? You may need to look back a few slides where I asked you to memorize the charges of the main group elements, the groups that end in A. And if you look at bromine, it's in the halogen group, 7A, and all of those elements, when they become ions, have a charge of -1. There are 3 bromines, so the overall negative charge in this compound is -1 times 3, or -3. Now the cation charge has to equal the anion charge so that there's no net charge overall. So that means the cation charge, the charge in the chromium, must be +3. See, equal to each other, +3 -3. So the name for the chromium in this compound is chromium, parentheses, Roman numeral 3. So we would call that chromium 3 and then bromide. Make sure you understand this page. It can be a little tricky, but it's important. All right, let's now talk about the other thing that can complicate the naming of ionic compounds just a bit. If you have a polyatomic ion, how do you know if you have a polyatomic ion? Well, basically, if you have 3 elements in an ionic compound instead of 2, you have a polyatomic. So look down here at the bottom. You have sodium, you have nitrogen, and you have oxygen. You have 3 elements. So that means you've got a polyatomic. And the polyatomic is NO2, right? So how are we going to name this? Well, luckily, Sodium is not a transition metal, so we're just going to call sodium. We don't have to worry about parentheses and Roman numerals. But since we have a polyatomic ion, we can't go trying to make up some funky name like nitrogen oxygenide something. You have to go to your list of polyatomic ions, which you're ultimately going to have to memorize too. And you have to see that NO2 is called nitrite. And so you just copy that exact name into the name of the entire compound. So NaNA2 is called sodium nitrite. Alright, so here's a chart for the polyatomic ions that you will need to have memorized. A lot of students tend to like to put these on note cards with a name on one side and the formula on the other. If I were to ask you the name or the formula of any of these on a quiz or test, you'd have to make sure you have the charges correct also. That's just as important as the name and formula. So you may want to print this out or else make note cards from it. Alright, this is just kind of a little quirky one-slide thing, but it's something you're going to need to be aware of. There's a type of compound called a hydrate. It's only a type of ionic compound, not a covalent type. And basically it's a compound that has water molecules actually bonded in with the ionic compound itself. And it's because water is very attracted to ionic compounds. And so some ionic compounds can actually pick water molecules up from the air and incorporate them regularly and rigidly into their crystal structure. So this little dot simply means it's a hydrate, and they are considered a chemical bond, and you have to name them. Magnesium sulfate can exist in the hydrated form and the non-hydrated form, so you need to tell people what form it's in. There are 7 water molecules that are part of the magnesium sulfate hydrate structure, and so you start out by naming it just like you would the ionic compound, which would be magnesium sulfate. SO4, of course, is a polyatomic, and then you would continue to name it. You have to say that it's a hydrate. It has 7 water molecules. The prefix for 7 is hepta. So the entire name is magnesium sulfate heptahydrate. Little tricky, but it's a good thing to know. Alright, so we talked about overall the names, but I'm going to give you just kind of a summary list. Always write the name of the cation first. The cation goes first in the formula, also goes first in the name. If the anion is not a polyatomic, if it's just a single element from the periodic table, all you do is make sure you use the suffix IDE. If it's a polyatomic ion as an anion, you need to have those memorized and just use the name of the polyatomic ion. Remember to always ask yourself if the metal in the ionic compound is a transition metal, and if it is, you need to write down its charge using a Roman numeral in parentheses. Alright, so do a couple here. I would suggest that you turn off my lecture and then you come back and try to see if you got it right. I'm going to sound like a broken record here, but by far everything I've discovered over the last several years is that problem solving, working problems on your own, and making as many mistakes as you can while you practice is the key to succeeding in chemistry. So even if you completely screw these up and get them wrong, then what you have questions to ask, either of me or a classmate, or try to get them answered yourself. But if you just peek at the answers, you're never going to know the mistakes that you might have made and that can be fixed. Alright, I'm hoping you tried these yourself. K2SO4 does not have a transition metal, but it does have a polyatomic ion. So I would start by looking in my polyatomic list and find the name of SO4, which has a name of sulfate. And so the name of this first one is potassium sulfate. The second one also does not have a transition metal, so you don't have to worry about that. But again, it has a polyatomic ion. You can see because you have 3 elements, barium, oxygen, and hydrogen, that tells you there's a polyatomic ion in there. Look up OH, and it has a name of hydroxide. And so the name of this compound is barium hydroxide. Now C, hopefully you caught that iron is a transition metal, and therefore we need to figure out what the charge on the iron in this compound is so that we can incorporate that into the name. So you always start by figuring out the charge on the transition metal by first figuring out the total negative charge in the compound. Chlorine is a halogen in group 7A. Halogens, when they become ions, always have a charge of -1. There are 3 chlorines in this compound, so I need to multiply the -1 charge by 3. So the total negative charge is -3. Because the overall charge of this compound must be 0, my total negative charge is -3. That means my total positive charge must be +3. So that when I add these charges together, I get 0. So it's iron with a +3 charge. So the name of this compound is iron, parentheses, Roman numeral 3, which means that iron has a charge of +3, chloride. Alrighty, so I'm going to work these out for you. Let's see, I'm going to use the blue pen. So potassium sulfide is pretty simple. Potassium is the cation. The symbol for potassium is K. And I will always allow you to use a periodic table on a test as long as it doesn't have writing, your own handwriting on it. And sulfide comes from sulfur. Remember that we put the suffix IDE on. And so we need to write in sulfur. Now, how do we know what the subscripts might be for potassium and sulfur? If you wrote your formula as simply Ks, then you got maybe 50% of it right, so that's a good start. But you have to know the charges of the cation and anion in order to know how many of each you need. So potassium, you may need to look again a few slides ago when I told you the charges of each of the group A elements. Potassium's in group 1, and so when those elements become ions, they have a charge of +1. Sulfur's in the same group as oxygen, and when it becomes an ion, it has a charge of -2. Remember that however many negative charges you have to have the same number of positive charges so that the overall charge of the compound is 0. Well, we don't have enough positive charges. Okay, we need to have a total positive charge of +2. How do we remedy that? We use 2 potassium. So the chemical formula for potassium sulfide, for potassium sulfide is K2S. You can double check yourself, kind of proofread, by checking your charges when you're done to make sure that you've balanced them. Sulfur again has a charge of -2. Potassium, when it's a cation, has a charge of +1, but we have 2 of them, so the total positive charge is +2. +2 -2 balance each other out so that the net charge is 0. Alrighty, let's go on to the second one, calcium hydrogen carbonate. I will tell you right now, kind of as a clue, when the anion name does not end in IDE, that means you have a polyatomic. Remember, every anion from the periodic table ends in IDE, like sulfide, bromide, oxide. So if you have something that doesn't end in IDE, you got a polyatomic. So you're going to need to look on your polyatomic list and see what hydrogen carbonate is. So what it is this with a charge of -1. That is our anion. And notice that when I write the elements involved in, I'm including their charges. That's really important for getting the formula of an ionic compound correct. Calcium is Ca. Again, since this is an ionic compound, I'm going to write its charge. It's +2. Now, I have to worry about balancing the cation and anion so that the total positive charge equals the total negative charge. I have too many positive charges. How do I do that? I have to add one more hydrogen carbonate. Okay. When I do that, my total negative charge is now -2, which equals the +2, and that's balanced. How do I write this as a condensed chemical formula? That's what subscripts are. So calcium, we only have one of them, so we don't show any subscript. The polyatomic hydrogen carbonate is HCO3. We have two of them, so we're going to put a 2 down here. Notice that when I write the final formula, I do not show the charges, because the final formula should be balanced. There should be no net charge, so you don't show any charges. Go ahead and try nickel perchlorate, and I've scribbled so much, I guess I can do it at the top up here. All right, so nickel is a transition metal, and the Roman numeral with a 2 tells us that the charge on nickel in this particular compound is +2. Perchlorate, you should have been able to pick up that that's a polyatomic right away. It does not end in IDE, therefore it's not from the periodic table. It is a polyatomic. And when you look up the formula and charge for perchlorate, it is ClO4 with a -2 charge. Aren't we lucky? I love when that happens. So already, just writing each of these, the positive charge equals the minus charge. We're already balanced, so we don't have to do any extra subscripts. So writing the condensed formula for nickel perchlorate, we have one nickel. And whenever we just have one of something, we leave out the subscript. It's understood. And then we have one polyatomic, ClO4. So really the only thing we're doing different is we're taking out the charge when we write the condensed formula, and that is nickel 2 perchlorate. That's it. This takes a lot of practice, okay? Even if for some reason it sounds easy to you now, please go to work on your homework, work on the problems in the back of Chapter 3, or I have posted a practice worksheet on our in-class folder and content, but work on a bunch of these.